Well, good morning and good afternoon, ladies and gentlemen. My name is John Burwell. I'm the global lead for simulation and training for Varjo Technologies. And it's my pleasure to bring this webinar to you today and be your host. The webinar's title will be From Contract to Deployment, Building an XR Air Refueling Simulator for the US Air Force. We have some really exciting content and speakers for you today to talk about this project that uses mixed reality, our Varjo training devices. So we'll have presentations from VR Training, from Talon, Bugeye Technologies, and last but not least, our Air Force sponsor from Strikewerx is going to be with us today. A quick slide on Varjo. I think a lot of you are familiar with us, but for those that aren't, our focus at Varjo is really building enterprise class headsets that support human eye resolution, that support the ability to see details and objects at realistic visibility ranges within the headsets. We really have a focus on mixed reality solutions using video see-through technologies and a lot of software that we've developed that help to mix that video see-through technology with the virtual environment, the computer-generated content. And I think you'll really see that today, how those tools were used and how it was implemented and building a real simulator. I think that's going to be the power of what you'll see today. We're going to go through the content and we will definitely leave time for questions. Best part of it to get your feedback and additional thoughts. So we will be using this tool that you can click on, and any time along the presentation, go ahead and submit your questions. We will be answering them at the end. So it's my great pleasure to introduce our panelists today. So first off, from VR Training is Neil Levin.
Hi, I'm Neil. VR Training develops cutting-edge, next-gen immersive training and simulators for today's warfighter.
Hi, I'm Brandon Nades with Talon Simulations. We specialize in extended reality simulator solutions for entertainment centers and training institutes.
Hey, good morning. I'm Kyle Zick, president of Bugeye Technologies, and Bugeye specializes in design and manufacture of flight simulation equipment, much like the equipment that you'll be hearing about today.
Hey, good morning. I'm Russ. I run the Air Force Global Strike Command's innovation hub called Strikewerx. We take the major commands' problems and their pain points, and we go out and find small businesses, large businesses, entrepreneurs, and vendors to help solve those problems.
Great. Russ, why don't you go ahead and kick it off from us talking about the project.
All right. We were asked by Air Force Global Strike Command to lead a challenge to help them with the hardest problem they've got when they're training B-52 pilots. They take a B-52 pilot right out of pilot training, and they've got to teach them how to fly this B-52 that you see behind a KC-135 in this picture. He's flying 12 feet behind that tanker. Their pilots do this in all weather conditions, day, night, cloudy, clear, sunny, and they're doing whether it's turbulent or not. So training that pilot how to transition from flying the trainers and pilot training to flying this 500,000-pound bomber that was built in the 1960s. Remember, the B-52, the first model was designed in the 1950s. Think about the technology we had back then. People were driving like a 57 Chevy. I'm trying to think of a car that everybody's going to understand. A 57 Chevy, you've got a large bench seat, you've got no power steering. The only option available was an AM radio. It's not a handling machine. They had a lot of power. You can put a big engine and go fast in a straight line, but it's not going to maneuver at all. And that's how the B-52 is. It's got a lot of great capabilities, but handling and finesse is not one of them. So teaching a pilot how to handle that, where he's got to move that yoke like you see behind me. He's got to move the yoke and the throttles, and that yoke takes 35 to 40 pounds to move that yoke, rotate it forward and back, left and right to get that airplane to respond. Pilots will actually build up a callus on their hand from doing that because they'll do that for up to 45 minutes at a time. That's the time that it takes to take on a combat load of fuel that you're going to need for one of these 30-hour endurance missions when you're flying around the globe on a global strike mission. So the challenge really that we had was to recreate this environment that you see behind me. the human factors folks want us to bring that environment together with the computer and the human to get that human machine interface. You've got to recreate the discomfort that a pilot experiences in the airplane and try and translate that into the where he's using this augmented reality goggles, where he's using this simulator. So you've got to recreate, in the airplane, you got to lean the seat forward, tilt it forward, move it all the way up, and then crane your neck to look up, you will see that tanker behind you. You've got to recreate that. You've got to keep your elbow up in a high position when you're working the throttles and the extreme forces it takes to move that yoke. So our challenge was to recreate that environment in a simulator so those skills will transfer, because that's key to that in learning environment. We contracted with a VR training to build a prototype. We gave them 8 months as a period of performance. We put them on contract in December, and they delivered their prototype to us in August.
Thanks, Russ. Challenges are like SBIRs, but SBIRs tend to be the effort of a single company. The problems and the requirements of a challenge like this call for technical solutions that cover many, many disciplines. As such, teaming is a super important part of the process. I knew that we couldn't architect a solution to the Strikewerx challenge without the input and effort from a team of small, like-minded companies. So I reached out to a few that I knew or had worked with before to help craft our solution. I was fortunate to be able to bring a great group together. They included Talon Simulations, Bugeye Technologies, Magic Bytes, Iris Dynamics, Silverdraft Computing, and of course, our host, Varjo. As a small company, I know that I'll be going up against these large companies that may already be familiar to the sponsor with lots of capabilities. I've learned that we need to separate ourselves from the crowd by proposing unique solutions, usually outside the norm. In this case, our solution was focused on providing a realistic experience and high fidelity simulation for the pilots. The hardware had to have the exact look and feel of the B-52 components. The simulator had to behave the same as the real B-52. Controls had to provide the same performance. And as a nod to the mixed reality requirements, we wanted to see real hands and arms on the throttle and yoke during the procedures. So our focus was on these key elements: exact duplicates of the B-52 hardware, a multi-use platform and component engineering from Bugeye, electromagnetic actuators from Iris Dynamics that could provide smooth, powerful control loading, full motion 3-DOF platform from Talon, who were also responsible for much of the R&D and the actual assembly of the simulator in Orlando. And as you may notice from this slide, in our original proposal, it included mixed reality and a backlit green screen for chroma keying. Bugeye was already looped in from the start, but once we signed a contract, my first call was to Kyle.
And I appreciate that call, Neil. Yeah, Neil called us and we started diving into this. And you know, the biggest thing that we focused on up front in a project like this is start with the pilots, start with the end users, try to pick their brains about what's important to them, what's going to make the training effective. And so we were lucky in this case because Russ and his team gave us great access to a great group of pilots that gave us all kinds of information. And gathering information is really where we had to start. So between, you know, picking the brains of the pilots, going and getting in a B-52 and scanning, collecting more data in the B-52, and then also using some flight manuals. Those are kind of the main avenues for collecting data that we have at our disposal. You know, there was initial talks about using an existing model, and really what we determined is that's just not adequate. You really need to combine all those data collection avenues together to get a full and accurate picture of what this simulator needs to do. And so, you know, when we sent a team of engineers down, we sent them with our laser scanner, very high fidelity laser scanner, and they went in the cockpit and they scanned every inch of that B-52 cockpit that they could to get accurate detail on every little piece. And the image that you see on the left is kind of what resulted after they took, you know, all that point cloud data from the scan, all the feedback from pilots, all the flight, you know, manual data, and put it all together and actually design and develop this solution. So what you see there is a high fidelity throttle for the B-52, a yoke along with the yoke column, and underneath the floor there are the iris actuators that Neil mentioned. That's what actually provides the force feedback to that yoke. A high fidelity seat, which we'll get into in more detail, but the seat is actually a really important thing, as Russ mentioned. They've got to feel like they're in the right position and that they're pushing how they would in the aircraft. If it falls anywhere short of that, it's just going to feel like a game and it just won't be effective. So again, starting with a pilot-centered approach, trying to figure out what's important to get the right level of fidelity. That's how we at Bugeye go about collecting data for a project like this to make sure that it winds up being successful. So to go into a kind of a detailed example, if you want to go to the next slide there, the throttle in particular is a really important piece, as was evident by the pilot interactions that we had up front. And so we had an interesting engineering challenge on the throttle where, in the real aircraft, there's 8 engines, there's 8 levers that you see there. But in the real aircraft, these levers are connected to cables, and those cables run hundreds of feet back to the back of the aircraft. And then those cables actually go out to the wings and control the flight surfaces. And so trying to reverse engineer that system and put it into this package that you see here on the screen, which is basically a cubic foot, and trying to replicate those forces and the feel of that, again, is a very interesting engineering challenge. And we identified pretty early on that this complex throttle was going to be kind of the long pole in the tent for us from the hardware perspective. We were going to really have to focus on this and for one, get it right, but also it was going to be this challenge from a scheduling standpoint that everybody's going to be wanting to get hardware in their hands and get it working. And so we knew we had to move quickly, and our engineers ultimately did a great job getting that those forces crammed into this little package that you see here, and a lot of the pilots, once they finally saw it, were just in awe of what we came up with on this throttle. So it ended up being a pretty good success story, but not without some hurdles along the way. So
thanks, Kyle. Glad you answered the call. This challenge began with 103 companies submitting solutions. Within a month, there was a down select to 25 companies, and then they wanted more detail from us at that point. The next round had a 10-minute video pitch, along with a 20-minute Q&A with the sponsors and the chief scientist from Global Strike. And this was our first drawing that we supplied for that pitch. We signed our contract in early December, as Russ said, and we had 10 months to deliver the prototype. After we signed the contract, we began ordering all the new equipment, filling in the details of the effort, and planning the next steps. And once Bugeye's new scan was done, we had a VR cockpit that we could work with. I love this picture from February 2nd. We're already 2 months into our build, and it's the start of our real R&D work. Jordan from Talon and Thomas from Magic Bytes began working on our initial prototype with COTS components. You can see here that we're using a rudimentary backlit screen, and the focus at this stage was building familiarity with the XR-3 headset to see hands and equipment inside the VR flight sim software.
Yeah, since this was the beginning of the project, we knew there was design and manufacturing of the hardware, and it would take a few months. So we focused on becoming familiar with the XR-3 and Varjo lab tools so we can understand what we could accomplish with the tools and the limitations within the flight simulator environment and chroma key. So with the goal of including the physical force feedback controls and your real hands within the virtual cockpit, we knew that we were going to have to use a green screen around the yoke and throttle, and we're going to learn how to create masks for that specific area and with lab tools. And because there was no other interaction with other instruments for this application, so that way we knew that was our main focus, was your hands and the yoke and throttle. And at some point, we were going to end up putting the green screen onto the motion platform as well. So it's going to have to be a dynamic mask and move with the whole machine. So we not only were testing the settings you needed, the green screen material, the lighting, but also how to create these 3D masks. And we ended up using a Vive controller and then figured out how to make them move. And we tried a QR code that the pass-through camera tracked, as well as a Vive tracker. And we ended up using a Vive tracker on the machine, tracking that, and it moved the mask with it. And these were the results of the first test. So here you can see the real hands along with the real yoke. Down to the left was also the real throttle. So we had this green screen set up and moved just with very rudimentary components. And we set up the mask in both of those parts. So that way you're seeing the your real controls, but everything else is virtual within the cockpit and outside the windows as well. So these initial tests gave us a good start at understanding the tools at our disposal and allowed us to move forward with additional green screen setups over the next few months, which Neil will discuss a little bit further.
And clearly we knew we were in the right direction at this point. We had enough sense of it from this very beginning. And so the next 6 months were a constant state of innovating our concept. We had a limited budget, and Michael's and Home Depot's became our go-to locations. We spent significant time on understanding how to light our solution and how we would construct the green screen. This is literally cardboard and copper tubing as we started out. Until we got our components from Bugeye, we worked every day really on refining this visual experience. Here we are in early April, 5 months into the project, and we've moved on from copper tube and cardboard. Jordan built an 80/20 stand that was mounted on the 3DOF platform to hold the COTS, yoke, and throttle in better positions. And Thomas was the mastermind behind our attempt to see if the backlit green screen would have enough power to eliminate the shadows created by the pilot's hands. But as you can see from the LED lights on the boom above the chair, shadows were still a problem for us. This video explains why the lighting was so important. The fuzzy, blotchy areas or noise are the shadows that we had to remove. We spent a lot of time working through this lighting problem and the final screen dimensions. On this drawing, we're getting closer to the final prototype. We've moved away from the backlit screen. It did just provide enough lighting for us. And as you can see, we now incorporate lighting in the boom over the pilot's head. We're very close to the screen dimensions, but at this point, the screen is still located on the floor and not on the motion platform. The lighting array has now become this larger overhead panel because of all the lights we needed. We have 3 LED lights and 2 more spotlights to cover the lower side areas. We still don't have a solution about how they're going to be mounted yet. We're still gauging the size of the green screen. And so all those lights are a perfect example of an over-engineering on our part, deliberate, or even delaying what our final solution was there until we move forward, later refining it on down the road. This video is from May, 6 months in. And you can see we have confirmation of our approach to the lighting. Minimal green tones, clear views of the equipment, nominal shadows. And you can see this is just the yoke and the throttle there on the right. These are real, and you can even see the legs down at the bottom to show how much the body was getting through at this point. By this point, we've received the bulk of the hardware from Bugeye, and we're ready to start stress testing at our design. One of the requirements of the challenge was that the simulator has to work for both the pilot and the co-pilot. From this drawing, you can see that our final positions for the lighting were above the pilot, but the boom construction still wasn't finalized. The dimensions and shape of the green screen are final. The simulator has to work for both the pilot and the co-pilot with relocatable throttle quadrant. So the screen has to be of equal shape on both sides. And in this particular view, we're looking at the left-hand seat, the pilot. And one of my questions to Russ and one of our questions to Russ was, well, how are you going to get into the simulator at this point? And will 22 inches really make it work?
And we told Neil that, yeah, 22 inches does work. You see behind me, the cockpit environment, you can see that throttle right there in the middle. And it's a common throttle used by both the pilot and the co-pilot. So he's got to reconfigure it. But that 22 inches does allow the pilot who's used to getting in by grabbing a handle back here. It's right above the window. And he grabs that, stands on the seat cushion, and then performs some gyrations to slide into that seat that he's sitting in right there. So they're accustomed to that, and Neil's solution is satisfactory.
And this is next slide is a good angle to show the curves of the green screen on the wings, since we didn't need to continue all around the same height. We're looking down at our elbow or arms. And at this point, we decided to work with an outside engineer to evaluate materials for the screen and settled on a custom plastic screen that was light enough to be mounted on the motion platform. I used to say that every day was a new problem, and almost always the team solved it the same day. But if you look at this image closely in the front, you can see that the pedals are almost at the bottom of the screen, and we didn't leave enough room for the pilot's feet.
Yeah, we actually were kind of aware that might be a problem, and were able to make some quick design changes to the green screen frame. And on there, so you got the aluminum frame, then the green screen itself is acrylic with green screen fabric on it. So we had to cut out this notch and ended up making plenty of space for it. And so that's just one of the fun engineering challenges that we encountered along the way. And the next step at this point was making sure we get all of the hardware integrated with the software. And we had a software engineer on site helping with that. We had to make sure that we got all of the inputs from the throttle and yoke communicating with the program, which it was developed in Unity in this case, as well as the outputs, because you needed to have control of the actuators. For the yoke, it had a pitch, which was forward and back force, and roll left and right. And so that needed to all be communicating properly, as well as the output of the motion profile to the platform. So those were all of the main components that we needed the software integration. We began fine-tuning more of the settings in lab tools for the green screen and making sure all of that was at least at a specific default area that we knew we might change on site, but at least gave us a good place to start based off of this lighting setup. And then we, once everything was kind of working and tested, we were going to begin doing wire management. We wanted to leave open the cockpit where we were going to house everything until we knew it was all working. And we're able to get things sorted out and make sure it's easy for maintenance and troubleshooting, which is one of the nice perks of the 80/20 cockpit. So everything's housed below. We had a power supply for both of the electromagnetic actuators. And so they use electricity to power the magnets, which make it a lot smoother of control loading. And so that was one of the benefits of using those, and what set us apart. And such a critical aspect of air refueling is battling with those 35 to 40 pounds of force in the yoke. Those had a control board as well that needed to communicate the input and outputs. The yoke and throttle each had a needed power and data transfer to the computer. And then even the seat had 3 actuators, because they are controlled just like in the real plane to move up and down, forward and back, and tilt forward and back, as you see here. And one of the other big aspects once we started with that were with the armrests that we found. And we asked Russ, hey, this is a little cumbersome. What do you think? Do we need these?
I told them it's essential, because you've got to recreate that cumbersome feeling that the pilots have. Those armrests have a critical function during the ejection sequence. This is an ejection seat, and the pilot's wearing a parachute. And those little panels on the side of the armrest keep your arms in there. So when you're air refueling, you got your elbow up and you're moving that throttle, that plate hits right in that corner of your elbow right there. And it's annoying, but you've got to keep that. You got to recreate that so you have a positive transfer of learning into the airplane.
Yeah, that was actually one of the things that we got very early on. We kind of picked up on that as a very important thing from the pilots that we were talking to. We didn't even have armrests originally planned to go on the seat. Then the more we talked to them, the more we realized that that they really needed to be there if they were going to replicate the training in an effective way.
And that was just one of the fun things during the testing period. And you can see one of our first like full motion tests in this next video. So the motion communicates in real time with the Unity engine through a plugin that's processed through middleware software that is translating that data into the 3 degrees of freedom of the motion. So you have pitch forward and back, roll left and right, and heave up and down. And we can actually tune those each independently of each other, depending on what forces are going to be stronger or less powerful in the aircraft. And we ended up tuning it to where we thought might be realistic. But then once we got some pilots on it, it got tuned down quite a bit more. You know, really your body just feels the onset acceleration cues. And so you really just need a little bit of motion here and there, especially when you're air refueling, where your goal is to remain in steady level flight. So you're not moving around too much, but this was where we started, and we're able to fine tune all of that in real time with the pilots.
Our team did their share of Q&A in Orlando without the final screen. And there was a lot of work going on, obviously, there as we integrated all the different components. But now it's time for the last set of testing. This is July 26th. We're 7 months in. We're almost done. We have like just days left to go before we have to pack it all up. The final screen is finally mounted on the 80/20 aluminum frame, and it's covered in a black skin. That same frame supports the light array, now down to only 3 lights, and strong enough to serve as the handhold for the pilots entering the simulator. We've got less than a week at this point to go before the simulator has to ship out. And over the next 2 days, we were incredibly fortunate to have Russ and Captain Blade Okai Jr. on hand to tune and stress test the simulator. We're not really pilots of B-52s, and so until we got them onto the simulator, we really didn't know how to really fly it the same way that they would. And so the first day that with Russ testing resulted in our issue of overheating of the actuators.
Yeah, we found that during normal air refueling, it's possible to end up holding the yoke at full rotation for a period of time. And that led the actuators to be holding that amount of force, up to 40 pounds, longer than expected. And it overheated the actuators to a point that they faulted. They cut off power to protect the actuators. And so we didn't really expect to max them out to that level, but we knew that we could apply active cooling to them. If you cool them down, we could increase that continuous power output 3 times. So then without the cooling. And we're able to grab a fan that we had in our warehouse. We actually use them for our race car and roller coaster simulators to blow wind into your face, and wired it into one of the power supplies. Got some duct work from Home Depot, and it was able to be resolved. Basically that day we were starting to increase the amount of strength to the settings that they were requesting, and able to prevent it from overheating. And so having them on site at this point before everything shipped was really a critical part of the project, because we're able to fine tune things, find these little issues that we wouldn't have done so ourselves because we aren't pilots.
But those actuators really did add a lot of realism. The feeling in roll and in the pitch for that yoke was very realistic. It models the aircraft and the simulator exactly with those control forces and the motion, and it feels just like the airplane, because you're actually in the airplane, you're pulling cables that are going through pulleys and bell cranks out to actuators out in the wings. Remember, that's a 1950 airplane. Those wires haven't changed, so they're recreating that feel. It was a very good decision. There was cost benefit, I know, because it did bring your heating problems, and it did drive a form factor. It enlarged the size of the base, but it did add a lot of realism and good transfer of learning.
Thanks, Russ. This is a short video of Blade flying the next day. Having the pilots in for these 2 days was key. We would never have been able to tweak the various motion parameters and adjust everything without their presence. And Blade was able to prove that we had a workable solution to the overheating problem at this point. We also learned that we didn't really fly the B-52 like a pilot did. Now that we've completed our testing in Orlando and run out of time, we had to ship the simulator finally to the Cyber Innovation Center. And now we're getting ready for the big event. The official fly off was Wednesday and Thursday, but we shipped everything on the week before and got it to the Cyber Innovation Center in Bossier City outside of Barksdale early in the week. So the simulator was shipped in 2 custom crates, reassembled, tested, and calibrated on Monday and Tuesday. And this was a demo space that they allocated to us. With the official fly off on Wednesday and Thursday at the Cyber Innovation Center, the Strikewerx team behind the event did an incredible job. Incredibly well run, executed to a T. The pilots came into our demo space in teams of 2. One pilot would serve as an observer instructor, while the other would fly. Then they would switch places. They've been briefed in advance and instructed on how to judge the event. And we also had a number of distinguished visitors, senior members of the AFRL, guests from other units, all were in attendance as well. Our simulator was finished up and shipped on Friday to Barksdale, and a week later, the B-52 students were actually using it. It was an incredible event. It really was. And I'd like to thank Russ and his Strikewerx team for putting on such a well-executed challenge. And I'd like to also thank our 4 pilot instructor reservists who served as our SMEs during the event and helped guide us during the project. Majors Budgeon, Tackett, Wolf, and Lieutenant Colonel Carroll. And thanks to Cassie and John from the Varjo team for hosting this webinar, and Russ, Brandon, and Kyle for their valuable input. We actually filed 3 patent applications for this design and certainly look forward to building more of them. And here's a wonderful video of the fly-off with great testimonials from the pilots about what they experienced.
Overall experience is I wish we had that, when I was coming up. Having something that I can go sit behind and kind of play around with and figure out my tendencies and kind of how the aircraft might react, especially with another aircraft in front of me on the ground where it's safe would be great. In the VR training that we have here, really, you get a chance to kind of set the conditions so I can build good habits correctly now on the ground.
What they have right now is the closest thing that we can get. It'll be great for the 11th Bomb Squadron to have initial qual, seeing how to actually fly before getting into the jet and being able to learn tips and techniques, save money in the long run for training overall.
I think these simulators are a great tool. I just finished my initial qual training, so I definitely wish I had this because AR is one of the hardest challenges for the new pilots coming into the B-52. Having the ability to practice and train in that simulated environment where conditions are stable and I'm able to focus on what I'm doing to influence that is really really helpful. Sometimes it's even little things like getting used to the indicator lights. When you're a first-time student kind of going up there, sometimes you get yourself backwards and you do the opposite of what you should have done, and a lot of those little brain tweaks can be worked out in the VR sim.
It was definitely a great experience today. Very impressive to see the technology that's been presented to us today. Air refueling is definitely a challenge for us. This just provides another tool for us to actually train to the things that we actually do. I see myself, if this comes to our squadron or to the FTU, I see myself using it more often than not.
Well, I've heard it and I can see it now that air refueling is really difficult. These sims are available during our FTU, then I'll definitely be using them.
Excellent. Well, thank you very much, everyone, for the great presentations and outline. I'm going to turn now to Russ and ask him for his perspective, on the project and thoughts about on how it went for you and from kind of an Air Force perspective.
We couldn't have been happier. This is a great project that we had. The Air Force was very happy with it. Those 24 pilots that came in and tested it, none of them really had very much AR or VR experience. And to take that broad section of pilots, most of them were more senior pilots. They weren't your young 20, 23, 24-year-old brand new pilots out of pilot training who've grown up with some VR a little bit and maybe got some gaming experience. These are, 40-year-old pilots who aren't gamers and they don't have the VR experience, but they really did enjoy the experience in the simulator. And I've used other sims that I can't say that for. They've got controllers that are difficult to maneuver. You got to get used to working them with your hands. And this was easy to adapt to. So those pilots had a very good response, and I was very impressed by that. And this sim is used every day now. It's being used by pilots that are going through that B-52 training for the first time. And they're in the schoolhouse. And they're chomping at the bit to get in these simulators and try and experience the flight, because they're waiting for their first flight. They haven't flown the buff yet, and they love getting in it and getting the feel of the airplane and getting a chance to refuel.
Excellent. So now I'm going to move to the Q&A portion of this, and it's great to see that we've got a whole lot of questions. So what I'm going to do is just kind of go through these and throw them out to the participants to answer them, and in kind of in no specific order. So one thing that I was actually wondering, is can you talk about positioning of lighthouses and beacons on this, especially with the motion, and if there was any compensation or anything done? So how did you work with the beacons in order to provide the helmet tracking capabilities?
Yeah, I can discuss that a little bit. We tested a few different setups at the office of 1 base station, 2 base stations, 3 base stations, and to determine what was the limit, like how could we get it successful and reliable with as few as possible. And we ended up settling on 2, and they ended up just being in front of the simulator at I guess 10 o'clock and 2 o'clock, and looking straight at you. So we weren't so limited with needing to look behind you as much or anything like that, but we didn't really have any issues with the tracking of the headset itself. And then we had the Vive tracker, which was attached to the top of the green screen right in sight of the lighthouses, and that was moving the mask for the green screen around. And we had an internal software for motion compensation, which allowed the relative positional tracking of the headset stay with you as you're moving on the motion base. So it's sort of a lot of different things working together in that aspect. And I do see there is a question about that chroma key, and we did use masking. So the idea with that, the mask on the green screen, it allows us to only have the chroma key in that specific area. And we wanted to make sure that it was virtual everywhere else, and that wasn't going to be a problem. So that's why it wasn't just purely green screen and chroma key, but we did utilize the masking to make sure it was where we needed it.
So related to that, can you talk about any alignment and calibration checks between the physical model and the digital data that you had to do, and that have to be done when each pilot comes in to use the system?
There was a one-time visual setup that was kind of a manual calibration within the end software, and that allowed us to, like, we would do a room setup, and then we would be able to move the camera position for the user to where it would be in the seat relative to the yoke or throttle. I think every now and then we need to adjust that for some pilots, but it wasn't, by the end of it, everything was kind of updated, so that wouldn't be necessary, since the amount of times you needed to calibrate the visuals was a requirement. So we always kind of considered how that would look and wanted to make sure that it was a stable calibration process and wouldn't need to be done all the time.
Great. So another question here. What is the max load of your 3DOF sim can work with?
At 750 kilograms. So we were pushing that on this one.
Okay.
And it actually is 220 power, but we powered it with a transformer, step down transformer, so it could go off of a standard US 110 outlet. That was also kind of a metric for judging these, is making sure that it's easy to set up, how many outlets you need, and all of that. So we wanted to make sure that it was easy and wasn't constrained to the power of that building.
Yeah, just to chime in on that one. One of the constraints or requirements was we had to fit in a regular kind of office space. Height became a concern at times with the boom and the once you elevate the platform up and the height of the screen and everything, that became just a concern, but it was nominal and handled.
Another good question here is about aircraft dynamics. So for a lot of these low footprint sims, one of the big challenges is the coming up with aircraft dynamics flight models that actually properly mimic the aircraft. I mean, how was that done in this project?
There's several questions on that. If I can just kind of touch, many different efforts came together to build this simulator. We focused on the hardware. The Air Force Global Strike Command asked us to focus on the hardware. Air Force Lifecycle Management Center, which is the simulator branch really for the Air Force, they had a SIBR going with another vendor to develop the software to run a simulator, and they had another SIBR going to develop the aerodynamics behind the KC-135 and the B-52 to model the downwash and the aerodynamics, because those are problems with the current simulator that they have right now that's just not realistic. So those were going on kind of in parallel with our hardware effort. And then we brought it all together, and I do see interest in that, but the Air Force did put some force measuring devices on the B-52 on training missions, and they would go fly, and they had some GoPro cameras also in the cockpit, and they'd be able to look at what the yoke was doing, what the pilot was doing with the yoke. At the same time, it was feeling different sensations, and that's how they gathered the data to get the amount of force and build that into the software.
So kind of related to that, does the sim take into account crosswinds and turbulence?
No, right now for this basic prototype to show what's within the realm of the doable, that was kind of our tasking. It's really just day visual flight reference conditions, visual conditions, and no turbulence. Those are features that can be added in the software at a later time. Again, that's all just software driven, but that's not in the current plan right now.
Okay. Question about the headset. What was the value proposition for using the Varjo headset vice a different option? Were other options considered?
No, we from the very beginning, we knew we were going with the XR-3. It was really a combination of where Varjo was at the time, the information that Varjo had been supplying to the public at that point, really worked with our with the requirements and what we think what we thought we needed, and it was really our singular choice almost.
And just to pile on there with Neil, the Air Force has asked us to work a couple other projects too with Strikewerx. We've got a Louisiana Tech University professor and one of her PhD students doing a study on how the Air Force teaches pilots to air refuel. Are they doing it the best way? How can we improve that? So they are looking at that. One of the things they're looking at is tracking the pupils. They haven't started this yet. They want to start collect data. When you teach a pilot to air refuel, you instruct him to focus on a reference on the middle of the airplane. There's a little UHF antenna that sticks down on a line. That's your center reference, but you want to keep your eyes moving peripherally. You're looking out to the engines on the left, the right. You're looking at where the boom operator is in your window. You keep this cross check going. So you keep your eyes moving and you can sense in your periphery if you're moving in or out on that tanker. So you see that before it becomes too late to maneuver and provide an input for that. So you have to keep your eyes moving, and there's no way to tell if the student is really moving his eyes. But now with the goggles, you can start to collect that data. We've also got another company doing collecting data for AI and ML and start to use some of those tools to figure out how well they're learning, how measure the performance. You can now measure that performance on the throttle and see, how many radians are they, how many degrees are they moving that throttle? Because the smaller your inputs, the better. The really experienced pilots, you'll barely see them moving the inputs on the yoke and the throttles. But a young guy, he's slamming them around, he's putting in big inputs, and he's really just creating more problems for himself or herself. So if you can start to measure that and then tell the pilot kind of how they scored, if you want to gamify it a little bit, and it's going to drive them to make smaller inputs, which is going to improve their skills. These are things that you couldn't do in the current simulator, and you can't do that in the airplane because you're not collecting that kind of data. And there's also studies being done that show they track the pupil movement on just learning retention and how well a student is learning something, and just by tracking the pupils. And that's kind of an invasive examination if it's another training task. If you're trying to teach someone how to ride a bike or how to sew or do something like that, having to wear some goggles is invasive. But since we're already wearing the goggles for this training, it's not invasive, and that's just another way, another tool that we can use to see how well they're capturing this learning task.
Excellent, good stuff. Got a couple questions in here on the compute and graphics hardware. Can you comment on CPUs, GPUs, numbers and all that and models and brands that were used in this?
Brandon, you got that one?
Yeah, it was a Silver Draft Demon computer with a A6000 graphics card. Intel CPU. I mean, it's one of Varjo's recommended providers, and we were like, give us the best that you got. So definitely enterprise workstation level.
Okay. And then other questions related to the runtime environment. What was approach in developing the simulator in Unity? Any notable software, development kits and that were used? And kind of along with that, why Unity versus other offerings that are out there?
Well, the first thing was why Unity was, as Russ had mentioned before, the software component, the simulation software component, was really dictated by the lifecycle management existing programs that had gone on. That had been a project that had been started before this challenge, and very early in the challenge, they decided to use that existing software, and it was built in Unity.
Okay. So I got a couple questions around that are related to sort of cyber sickness and also sort of having older pilots using the technology. During any of the evaluations, were there occurrences of cyber sickness, simulator sickness, and what were the experiences, or were there experiences with some older pilots, and any kind of pushback on wanting to use HMD based training systems versus more traditional approaches?
I haven't heard of any cyber sickness, and I'm a 57-year-old guy, and I've got 2,500 hours in the B-52, and the first time I really used a VR device for anything more than 5 or 10 minutes was when I went down to visit and to see how they were doing in July. And Neil had me in the sled for probably 2 or 3 hours, and I didn't have any issues.
Yeah, one way we combat that is just trying to replicate as best you can what your brain is expecting to see. And that is one main reason we implemented your real hands versus ghost hands or avatar hands. There's no disconnect in what you're doing with your body and what your brain is seeing, as well as the motion platform syncing with what is happening in the aircraft, especially with flight simulators where you're flying around, and if your body and your eyes it looks like you're moving, but your inner ear doesn't feel it. That disconnect also gets a lot of people sick. But as well as the resolution of the headset. I mean, everything, just using an XR3 in general is going to make people have less cyber sickness, along with all of the mixed reality components together. This would definitely be a platform that would limit the amount of people that get sick on it.
John, if I could kind of hinge on what Brandon just said too, with
Sure.
There's other questions about, did you really need all the features of this device? Did you really need that pass-through mixed reality versus a virtual reality to teach air refueling? This project is really about it's technology transition from the commercial sector into the military. It's teaching the military what is being done in AR, VR, what's it best used for, what kind of features do you need for the simulator that you want to develop and the tasks that you want to train. And that was something that we learned on this project is for strictly an air refueling training, do you need the pass-through video and the mixed reality? And the answer is no. We learned that no, you don't. It's kind of neat to be able to reach out and grab that yoke with confidence and know exactly where it is. Same with the throttle. But after you do that, and after the sim set up and you're training and you're flying for 20 minutes, you're looking primarily out the window at that tanker and maintaining position visually on the tanker, and you're not looking at your hands or the throttle because you know where they are. Now, for other things, if this trainer was modified or there's another trainer built on to do other things, say to do touch and goes in the pattern, to come in and land, where you've got to reach out and grab a gear handle and raise it and lower it, or a flaps handle, or you got to turn down and turn the crosswind crab. So you're looking around and you have to interact with more physical things, and you want that tactile feel that you get just like in the airplane. That is where you're going to need that pass-through video to be able to interact with your physical environment right around you. So that was a lesson learned.
So there is a question there about the evolution of the requirements and how that was how that happened. And it sounds to me like it sort of evolved as you were going through and testing and it's kind of through trial and error. I mean, could you comment a little bit more on any requirements evolution that you went through and how that process was handled?
Sure, that gets back to our challenge process. So before we even put Neil and VR training on contract, we had what was called a problem definition workshop. So we bring in companies, we bring in small businesses and innovators, and they come in and we use these folks to help us define the problem, to write the problem statement, because the government doesn't know what they don't know. They don't know what's even feasible, what's being done. They're just that out of touch. And that's why they use Strikewerx to bring in these experts and help write problem statements. So when it is published, so when we call it the challenge, but it's like a request for proposals. When it's sent out to everyone and it's an open competition, it's in terms that industry is going to understand. And it's had multiple people question already, so you've already answered a lot of the obvious questions. So that's how we start that. We have an open process with several webinars, again, more two-way conversations. There's a lot of learning that goes on for the government. This is not a static write or RFP, get your responses, choose the lowest bidder, and then have them go bid it. That's the old acquisition process, but we're a lot more fluid, a lot more back and forth. And as that learning happens, those requirements change. If we started out, we wanted also a virtual instructor. You wanted somebody in the headsets. This is an idea that you got to tell the pilot, give him tips as he's going along. You'll have a little avatar maybe that pops up and coaches the student, so you don't even need an instructor there. That was one of the ideas. And while that technology is out there and it's useful in some places, we learned that that's technology is not technology on that item. So we eliminated that requirement, just as an example.
If I could follow up on Russ too, this was a really complex challenge. The requirements were it was broken into a number of different sections of what they were looking for, and there were a number of just options that were mentioned in each of the areas of the requirements, and it was fluid in the beginning, and there was when it came down to being selected, there was also a period of time where Russ and me and the SMEs had a lot of back and forth about really what we could what we could put in, really what we could afford with the budget, what we could put in, and what did they want us to see, what market research did they want to see for the challenge. And I thought that it was very collaborative through the statement of work process, and the SMEs that were associated with this project, I can't speak highly enough of them. They were incredibly intelligent. They were they knew what they wanted, and they were just really helpful. And I think all of us working together collaboratively to solve to answer some of these market research questions.
Excellent. So another kind of topic here, I guess, is sort of cybersecurity, RMF, IA type things, ITAR issues. So did you run into any of those issues? How were those handles? And also, will this presentation be available after, and are there ITAR issues with it?
I'll say this is a standalone, independent simulator. It's not networked. It's not on any Air Force systems. So for this prototype demonstration, it's not on. We don't need an authorized to operate or a risk management framework process, but that would be needed for a future fielded development. And yeah, there's no
issues.
We don't have any reasons not to share this video.
Excellent. So question on acoustics. So were acoustics provided, and was there value add there?
There was not so much effort applied into like the audio of the application. There's so many other priorities that we ended up not really having much sound at all, besides like the engine roar and then the contact of the air refueling.
But that contact is value. That is value added.
The clunk.
Yeah, there's a clunk when the tanker's probe goes into the receptacle on the B-52, and in the airplane you can actually feel it and hear it. To know that you're in the correct position. So you need that feedback, and that was good value added.
It's probably good to say too, like that content development is an ongoing effort with another software company that we were partnered with to integrate this hardware platform. So there's a lot going on with that aspect of it that we're not involved with, that has some of these other limitations and things like that. So
excellent. So we have time for another question here. The good question here on, have you tested a configuration with 2 or more of the systems networked together, so you can do sort of side-by-side viewing or networked versions of this? Have you looked at that?
The software developer has done that and demonstrated that. With the software, I mean, you can play it back too. We can use the VR training. You can perform, you can fly for 5 minutes, and then the student can take his hands off, and you can run it back and then push play again, and he can see his performance, what the controls, and the controls are physically moving. The yoke's moving around in front of you. Your hands off. You're just watching these big inputs when you were a certain place behind the tanker. So you're recreating that training session. You're seeing that, but the software developer has networked, shown that version of the software, that capability, and have multiplayer.
Okay. And actually, one other one that I'm also curious about is sort of data collection. So we talked about, using, eye trackers for, performance assessment and things like that. Was there data that was collected from this, or could there be data that's collected from this for human performance assessment or other purposes?
That's an ongoing project right now. That's us trying to figure out exactly what data do we want to collect? How do we write it to a file? How do we, capture that file, offboard it so you can go to the data analysts and they can analyze it. That's an ongoing project.
Excellent. So, once again, I really want to thank all of our participants. Fantastic presentation. It was just really good to see a real practical example of how this technology can be integrated together, really going over the challenges of this project, and with just a lot of good data about really the challenges and advantages and the benefits that you can have with this. I want to sort of conclude here by inviting everyone to come and see us at ITSEC, where it is the run up into the ITSEC conference here that's coming up at the end of the month. Most of us, or all of us, will be represented here in different booths. So Varjo will be at, you have our own booth there. We'll be highlighting all sorts of our mixed reality, virtual reality technology. Other participants, from VR training in Talon will be in the Rave booth, where they will be showing off versions or some of this technology there. And then last but not least, Bugeye will be having its own booth where you can go and take a look at their technology. So with that, I think we'll call it. And once again, thank you all very much. Really appreciate everyone's attention, and contact list for you to feel free to reach out to us if you have any other questions or thoughts. Thank you.